It's a pleasure to be here this morning. It's interesting how this presentation came about. I was doing presentations on affordability and affordability process and presentations on cloud computing and the cost of clouds, and somebody said to me, why don't you put them together? They're so tightly interwoven these days. So that's what I've done. 3 key points. Viable affordability decisions yield project achievements. Understanding affordability, the fact that something, it's worth spending the money or the resources to accomplish something, helps make much better decisions in IT and in computing. 2, cloud computing usage is becoming viable for more situations every day. And 3, applying affordability processes to cloud computing decisions can help assure a positive return on investment so that you're spending money where it's actually helping rather than in areas where it may not produce a return. Everyone's seen charts like this before. 22% of the IT budget of the average Fortune 500 company wasted. $57 billion wasted annually in IT projects that fail or are challenged. Cloud computing doesn't solve this. In some areas it makes it perhaps more cost effective. In some areas it doesn't help at all. But one of the key messages of this is that cloud computing is wonderful where it makes sense. It doesn't always make sense, and that's why the affordability and return on investment analysis is so important. Now, I built a process for affordability some time ago for both IT systems and for other kinds of systems, but I'm going to go through the 10 steps of affordability really quickly. Then we'll talk about a few of the steps during this webinar. I'm not going to talk about all 10 because there isn't time. First one is establish the key performance parameters, the things that have got to happen for this system to make sense. Whether it's being able to handle 1,000 users or respond to a query in 2 seconds or whatever it is, whatever they are, establish those so you know what the definition of success is and what the definition of failure is. Identify the various affordability goals and the figures of merit, the things you're going to use to measure the affordability. Important again to say, what are we really trying to accomplish here? Gather requirements, features, and performance the best you can. This might be at a fairly high level, but some kind of an idea of what it is you're trying to accomplish is necessary. Then defining baseline alternatives. Well, how can we solve this problem? Well, alternative A might be using a software as a service alternative. Alternative B might be doing something on premises. C might be doing it not at all. And the ground rules and assumptions around those so that you can cost them and figure out the returns. Perform enough technical design analysis for each alternative to be able to do a cost analysis. Now, this doesn't have to be drilling down and doing all the analysis, but it does need to be enough, a little bit of thinking so you know what it is you're trying to do. Do the actual cost and schedule analysis for each alternative so that you have a way to measure their robustness and returns. Again, assess the benefits both based on the cost analysis and other figures of merit. It could be that the best value is spending more money on one alternative than using the lowest cost one so that you get the best value to the organization. So assess the benefits based on those criteria that were deemed to be important, the figures of merit. Perform a risk analysis to see how things will go rather than just doing the most likely or boy, we sure hope this works, but actually understand the probabilities and risk. Assess the alternatives, choose the alternatives, and then document with lessons learned. Now, some of you might be rolling your eyes and saying, I don't have time for all this. These steps can be done fairly informally, but I recommend doing them for each affordability analysis. Now let's talk about cloud for a minute. There's 3 basic definitions of cloud. You can find gazillions of them if you look around, but these are the 3 that NIST has defined and that the Association of Standards have defined. The first one is infrastructure as a service. It says you run whatever software you want. You just use the internet to use it. The servers aren't in your offices. They're somewhere in the, quote, cloud. The second one is platform as a service. Platform as a service includes the infrastructure, but it also provides a way to build the software that you want. So you can use tools such as Salesforce.com or Force.com is one of them to actually build an application that runs on the infrastructure that's off your premises using a platform or software that you can use to build your application more quickly. And the third is software as a service, where the software actually runs on the internet. So you don't have to have it in-house at all. You go buy a license for Salesforce or Microsoft CRM or whatever, and it's running somewhere else. You don't really know where it's running. It's somewhere in the quote cloud, and you use it. You don't have to program it. Somebody else is doing all that. You still have to maintain it, maintain your help desk and things like that oftentimes. If you look at the framework of a cloud, and this is directly taken from the National Institute of Standards, we can see some of the essential characteristics. For example, the cloud generally has rapid elasticity. That means you can get more or less of it as you need it. You can measure and understand how much service you're using. It's available pretty much on demand. Resources are pooled. You don't have to have a server and add another hard drive. And there's all kinds of other characteristics. It may be virtual. Software may run low cost on it. It may be geographically dispersed. You may not know, probably don't know, where the cloud computing is actually hosted. Now, looking at key performance parameters, I've now switched into the affordability process. These are critical things where if you can't do them, the project will basically fail. They're essential for meeting the capabilities. They contribute to the enterprise, achievable and affordable. Well, notice we got affordability in its potential key performance parameter. Does it make sense? If it's not met, one of the tests for a key performance parameter is if you can't do it, the project may be killed or restructured in some way. Step 2, looking at figures of merit. Figures of merit are quantities used to characterize. For example, calories in a serving. If you go have an ice cream cone at Baskin-Robbins, 800 calories or whatever it is a figure of merit. It's a measure you can use to evaluate if you should eat that ice cream or stick with your tofu. Things like battery life in your laptop is maybe a figure of merit. This thing will last for 3 hours or 6 hours. So these are, whatever they are, they're characteristics that are the criteria that you can use to evaluate if this particular solution is going to be viable. Here's an example from NASA of figures of merit. Here we can see safety criticality. You don't want to blow it up, and effectiveness. How much does it weigh? Because it costs more if it weighs more. How far can it go? Can it make it to Mars, etc. So figures of merit are specific to the organization and to the product. In an IT application, one of the figures of merit may be, can we access this from anywhere, from our mobile devices, from our desktops? Maybe a figure of merit in a particular system. Is our data secure, etc. So whatever those are, and they're different for every program, identify what they are so you've got something to measure against. People are saying all the time, is the cloud secure enough? Is the cloud fast enough? Is the cloud vendor reliable enough? Will they be there tomorrow? There's lots of other figures of merit. Again, every case is different. We can't always say that cloud or on-premises is better. We've actually used both in Galorath internally. I'll show you a little chart. I spent some time looking at how we do it, what we do, and figures of merit are based on the individual application. Now, there's all kinds of horror stories about cloud computing. Of course, there are horror stories about on-premises computing as well, but there's more and more malicious attacks and accidental data loss based on the cloud. Looking at outages, in 2010 and 2012, 568 hours of downtime between 13 major cloud providers cost customers about $72 million. So the fact that it's in the cloud, if it goes down, you go down along with however many hundreds of other or thousands of other companies that are using it. When it comes back up, hopefully you'll come up quickly, but it's sort of out of your control. Now, being fair, if your soft servers go down in your your on-premises systems, you've got the same problems. Learning curve. Sometimes it takes time to figure out and understand the cloud. A vendor lock-in. If you choose a particular cloud provider for particular applications, you may be locked to them forever. If it doesn't meet the needs or other things happen, you could be pretty unhappy. Portability, moving data around. Software modification costs if you've got a platform as a service where you have to do the work yourself. And setting up a software as a service system. These are all things that have caused people problems at various times. Now, in doing affordability processes, one of the issues is coming up with the assumptions. In order to quantify what we're doing, to understand ground rules, whatever the ground rules are, the things that have to happen, and the assumptions, the things that we think will happen. It's important to identify, I believe, the major assumptions for every affordability trade. We believe this system will handle 200 users. This system will have an annual update from the vendor and will get us the functionality we want, whatever they are. Well, the problem with assumptions is you might be wrong. So rank ordering the assumptions based on their impacts, positive or negative, opportunities or risks is the next thing. Identify the high-ranking ones, the ones that are really important, that are risky, things that if you're wrong are going to cause big problems. Then analyze those change drivers, figure out what's going to happen and what the costs will be if these things go wrong. I can't tell you how many times I've seen estimates, and we've been reviewing estimates for decades, where people will say, well, here's my estimate, and here's my assumptions. And then they'll say, well, based on my assumptions, my estimate's right. We say, what if something else happens? They say, well, it's not my problem. Here's my assumption. That's wrong. Identifying assumptions that can go wrong is, I believe, a key part of any affordability or cost analysis exercise. Again, assumptions, people sometimes overstate them. Here's some interesting information. Douglas Hubbard, who's one of my heroes, wrote a number of books. So one of them is How to Measure Anything. I highly recommend it. Does a thing where he calibrates experts. Now, when people want to find out something, they'll often go to their experts, subject matter experts or others who they think really know what's going on, so they can get answers. For example, how big will the software be? How much will it cost? How long will it take? Well, looking at the percentage of the time that people are correct, using Harvard MBAs, they were correct about 40% of the time. If you're from MIT or another MBA, I apologize, but by the way, they're wrong, 60%. They went to a chemical company, and using general industry data, they're experts. The people that should know everything were right about 50% of the time. When it was company, so if it was generally about the industry, about half the time they were right. If they were it was about the company, 48% of the time they were right, or 52% of the time they were wrong. The assumption they gave you about cost or anything is wrong more often than right. Looking about in another study, company managers about the general business had 17% of the time they were right. Company specific, 36% of the time. Now, there are ways to calibrate this, and we'll just touch on that. But I highly recommend this book, How to Measure Anything. But what's my point here? If you just say, okay, we're gonna do our affordability, and we'll ask Joe because Joe knows everything. Joe might know everything, but the odds are Joe's going to give you overconfident or understated answers. Now, this bad assumptions and bad overconfident experts can cause your affordability trades to go wrong. So it's really important to spend time on this. Identify where these things might be wrong. Let's look just a simple thing you can do to make it better. Oops, I thought there was a simple thing in here. I guess it's, guess I put it somewhere else. It'll come up later in the thing. Sorry. Looking at estimates. Bad estimates are a root cause of project failure, whether you do them with Joe, the expert, or whether you do them with models or whatever. And a proper estimate should have a probability and associated with it. So if I say this is 12 months, just saying it's 12 months isn't good enough. There's a 60% probability we can get this in 12 months is really a full answer. Some people say, well, we can't estimate in the cloud, right? It's so different. Well, the cloud is really pretty much the same thing. We know how to estimate systems. We know how to estimate returns on investments. There's no reason we can't estimate cloud systems. We need to be careful. If we just use the vendor's statements about performance and availability, et cetera, we might have some surprises. But everything to estimate the affordability of a cloud system or cost of a cloud system, we know how to do. It's applying things that we already know. It's also important to remember not every system should be built. Affordability trades might show that some systems shouldn't be built at all because they'll never produce a positive return. You'll spend more than you'll ever get. And by the way, just using the cloud doesn't solve uninformed decisions. Looking at trades and what something should cost and what you can do to lower the cost is another important attribute of doing affordability analysis. What can we do to make this more affordable? Are there things we can do? Can we change some of the requirements, or can we compromise here or there? Can we use a cloud? Are all things we can use to figure out how much something should cost? Again, you can find studies that are on the positive side or studies on the negative side. Here's a study, this is actually out of Forbes magazine, that shows that cloud computing solves the world's problems. Startups, it's easier for startups. Obviously, if you're a startup and you need computing facilities, you can go to any of the cloud providers and have them tomorrow just by giving them a credit card rather than having to go out and buy expensive infrastructure. That's great. That's obvious. According to some studies, 50 to 67% lifecycle cost savings in a 1,000 server deployment. Greater return on investment and shorter payback with cloud. Deloitte made that conclusion. The government says that infrastructure as a service should save 7-to-1. Rather than buying your own servers, etc., using government-provided or other cloud computing systems can do a 7-to-1 return, where it's much cheaper to use a cloud. I know in watching some of our cloud systems we use here, we've seen the cost decrease dramatically just over time. Everybody's competing now based on cost. Platform as a service can increase cost. Remember, platform as a service means that you're going to use their tools to develop your applications. You may be stuck. Microsoft has said, be careful, don't do that, because you may not be able to get back to Microsoft. Other studies show that one analyst shows that moving to the cloud costs 30% more than just doing things in premises. In that case, it was platform as a service, where they were going to use the vendor's tools that were going to basically redo an application. This is a very small sample of a work breakdown structure looking at a cloud system versus a on-premises system. And this is done with our CRIT model. I'm not going to demonstrate CRIT, but here we can see on the left an internal host it yourself and a cloud-based multi-tier use the cloud. Here's some of the answers. I am not saying that cloud systems are always cheaper. They may be more expensive. They may be unviable. In this particular example, using a cloud system saved 45% of the total ownership cost because you didn't have to have people in there setting things up. You didn't have to buy servers, etc. Every one is different. Here's a more detailed estimate of an internal cloud. Here we can see the risk analysis. Most likely, we can see this is going to be about 30,000 hours. If things go wrong, it could end up being significantly more, or if everything goes right, which never happens, this thing could be about 20,000 hours. So understanding the risk and uncertainty is an important part of the process as well. Looking at figures of merit. Finding the best bang for the buck. I love Augustine's law, the law of insatiable appetites. The last 10% of performance guarantees a third of the cost and 2/3 of the problems. Sometimes we may just need to be compromised and take that extra half a second of response time or whatever to find out, to determine what will actually work and how we can do it most cost effectively. Here's the slides I was looking for a minute ago. Looking at risk analysis a little more. And if you look traditionally what people will do, hey, Joe, how long is it going to take to do step 1? And Joe might say 30 hours. And step 2, 50 hours. And we might ask Sam, the other expert, how about step 3? And he might say 80 hours. When we're all done, we add them up. We say 500 hours. Great, 500 hours. A better way to do this is to quantify uncertainty. Joe, Sam, etc., tell me your best case, your likely case, and your worst case. Now you'll notice in this slide the expected is still the same as it was in the prior slide, but here we were able to ferret out uncertainty because your experts have uncertainty and they often know it, and if you don't ask them for it, you don't get it. In this example here, we know a best case, a likely case, and a worst case. Still, the expected is 500 hours. Let's suppose we plan for 500 hours still. Running a risk analysis, looking at the 500 hours, there's about somewhere close to a 0% probability of making this thing actually happen in 500 hours. There's a 90% probability, remember I've said hours with days, I'm sorry, a 90% probability in 731 days, when the original estimate, had we only used a single point, would have been 500 days. This would have been another failed project, and they would have blamed IT and whoever else, and really it's because they didn't do enough to draw out the risk and uncertainty. You know, I believe that IT and IT systems is responsible for the development of a business case. I know people say, well, it's the responsibility of the stakeholders, and it is, but we're the ones that understand how to do this. We're the ones that have the quantitative experience to be able to draw out the information and build viable business cases. So the business owns the benefit calculations. I believe that the technical people should take and help figure out the business case and the ROI. Not everybody agrees with this. There's lots of metrics for the cloud. You know, what's going to cost? What's the value to the business? What's the quality? Yeah. What's the performance and reliability? Is this thing going to be slow? We have a cloud-based CRM system here, and sometimes it's pretty brutal. I won't tell you which one. I probably will tell you which one it is in a minute. But sometimes it's very quick and sometimes it's just slow. And it's because it's in the cloud. We're sharing the bandwidth with I don't know how many other thousands of companies. How usable is it? How satisfied are your customers? That's probably the number one, the voice of the customer and customer satisfaction. Is this thing doing what they want, cloud or not? Is it doing what they want in a way that they want? Is acceptable? Just another study, again, you can find studies everywhere saying the cloud is wonderful or the cloud is disaster. In this particular study, they found that they went ahead and had to use platform as a service, and it was a monster to rewrite the applications, just a monster. The cloud economics completely fell apart because they had to take an existing application and rewrite it so that it could be used in a cloud environment. Potential disaster there. Now, of course, the vendors will say that rewriting it is free or cheap. We've actually done studies saying in some cases it is cheap, but still could be a disaster. I think I already talked about this slide. This is an interesting case study, and whether it's in the cloud or not is almost irrelevant, but let's look at the issues of affordability. Levi Strauss, you all probably own a pair of Levi's somewhere. They decided they needed to do an ERP system, and so they contracted, budgeted $5 million, contracted to do an ERP system. The risk seems small. It should be a piece of cake. When they got it going, though, they found out the difficulty in interfacing with their customer systems. Everybody wanted their systems to talk to one another. Levi Strauss had to shut down the entire production of all their products for 3 weeks. They were unable to fill the orders for 3 weeks. So a $5 million IT project failure cost $192.5 million in lost revenue, lost earnings. This is a $192 million failure. And one of the things that happens is IT projects touch so many aspects of an organization, they themselves become a whole new risk. And so when looking at risk and risk analysis, it's important to look at what's the risk if your CRM isn't going to work, or if something else goes wrong. What's the risk to the business overall? If we look at software development, traditional on-premises software development, we've got development here, which is this little piece, and maintenance, about 75% of the development itself. IT services and IT infrastructure, between them are often about 60% of the overall total ownership costs. Well, what happens if it's a cloud? We might be able to get rid of that development. That's a good. Might be able to get rid of the maintenance or some of the maintenance if we don't have customization. That might be good. And we might just be able to use that 60% of the effort for the infrastructure. Get rid of some of the 60% of the effort for infrastructure. So this could be really, really cheap, but there are other costs that might occur. Again, we might have to quadruple the bandwidth in the organization to be able to handle the data going in and out. It might not meet the requirements appropriately. We might have to customize it. So again, my real point here is I can't say just because it's in the cloud it's cheaper, nor can I say just because it's in the cloud it's more expensive. Every one needs to be analyzed. If you look at some of the things that goes on in the labor and materials and things, the biggest labor you're buying servers and storage and networks and environment and administration of those are all things you might be able to get rid of in the cloud. The hardware, the heavy iron stuff. You still may need managers and analysts and architects and developers and trainers and things like that to accomplish your mission, depending on what your mission is. So it's important just not to say the cloud solves all problems. Now, some people say, well, Dan, this is easy. All I got to do is go onto the web, and I can find the costs of any of the cloud providers. It's like a no-brainer. And here I went and did something and actually snapshotted the cost of something or savings of something. And in this case here, they said that the Amazon was going to cost them about $45,000. Doing it in-house is going to cost them about $250,000. Sounds like a no-brainer. Unfortunately, if you look at the costs that Amazon lists, they don't include any of the internal services costs you might still need. They don't generally include bandwidth and things. They show what would happen in the best case. Now, that's a really good thing to know, but my recommendation is always look at the likely and the worst case as well, not just that best case, and this is the best case and probably doesn't capture all the costs. Now, since I took this snapshot, Amazon dropped their prices 30% again, so there's great things happening in pricing with the cloud providers. A lot of people say security. I can't put my stuff in the cloud because it's not secure enough. That may be true, but there's research that's showing that multi-tenancy is not less secure. Using cloud-based multi-tenant applications may actually be more secure because there's more work that can be done to secure them. There's more effort that can be spent on security. And security itself, again, is a very costly, here we can see the cost of building security yourself. If you have to build it in this example here, if there's no security, we can see there's about 400 and something. This is probably effort months for this example. If you got to make it as secure as possible, it can be, you can see, up 400% more. So building security into your own systems, which tend to be on the web now and in different ways people can access them, can be 400% increase in the cost of your own systems. Using the cloud can actually save you money. It may not, but it can save you money in security if you choose a system that's secure enough. You can find security studies in the cloud. You need to do your own as well and see if the particular system is secure enough for your own environment. I know some of the things we're doing, for example, at Galorath, for people that want to put Seer in the cloud, they can get Seer on the Amazon cloud or other clouds, and in their own virtual machines, they control it completely. It's not multi-tenant. Maybe it is in the large, but Amazon or the others have hidden that, and it looks like their own virtual machines, and they can have what seems like on-premises. I'm not saying if it's more secure or not, but it sure looks like might be viable for many things. We talked about that. Now, one of the studies that got us most interested in cloud, we were approached a couple of years ago by the FAA, who said they were looking to put some of their work into the cloud. They were looking at Force.com, which is the platform as a service that's provided by Salesforce.com. It's the components to build your own applications under the Salesforce platform. And in looking at that, we found it could be generally 30 to 40% less expensive than using Java, with about an 80% reduction in the best cases if it was exactly the right kind of a system. Now, Force.com isn't right for everybody or everything, and we're not recommending Force.com particularly, but any system that has a platform that allows you to build things quickly can generate significant cost savings if used properly. Now, if we look at the cloud and we look at mobile devices, most of us have mobile devices here. Before we started, Kelly was just showing me her kids on her iPhone. Everybody's got an iPhone or an Android or something, and we use these applications and we think they're in our phone. Well, if you look, there usually often are servers that are holding in data, and the local mobile devices are communicating with those constantly. There's services being used. There's APIs or programming interfaces between them that can go wrong, by the way. And if you look at, for example, this is Instagram. I don't know if you use Instagram or not, but if you use Instagram, Instagram has 25 different services that they're depending on. They're using the Amazon cloud. They're using proxy servers, tax queuing. They're using Apache web hosting kind of things. All these different things are being used. 25 pieces all working together to give you Instagram. Now, if you're in the software or IT business, you might think, oh my gosh, what happens if one of these things change? How do you retest it? Well, therein lies the risk. Yeah, there are potential nightmares lurking, and I hope we don't see them, but the odds are we're going to see some of them. I'm not saying Instagram particularly. This is not an uncommon setup. I went through Galorath here, and I said, what are we doing? And I walked into, we had a server room. We just moved our offices last year, but before then we had a server room. We had a raised floor. It was fantastic. Run cables under the floor, but we had overheating problems. And one day we had a 3-day outage. The building lost power. Something blew up. And we've got power backup systems, but the backup system blew up as well. And for 3 days, the whole company was down. We had no access to our email or anything on premises. Our buildings are threatening to charge us for power usage if we use more than X amount of power. We've got people scattered throughout the U.S. and Europe and Australia and everything, and we're already dealing with remote access and virtual private networking all the time. We put in Microsoft Dynamics CRM last year. We made a decision to use the software as a service version, so we're using the cloud version of Microsoft Dynamics. Now, Microsoft did a nice job of hooking it together with Outlook, so it sort of sometimes seems like it's local, but sometimes it can be pretty slow. We have our mail servers we host in-house. We're right now looking at taking those and putting them outside of Galorath into the Microsoft cloud for 2 reasons. One is, if things go down here, we've got no decent backup. We've got a cloud-based, I don't think I listed it, a cloud-based thing that does our spam checking that can kind of get our email for us. But putting it in the cloud looks like it will solve a lot of problems, and we don't have to ever upgrade our mail system again. It'll be done by somebody else, and we don't have to back it up every day. Good news, bad news. Right now we have backups from years and months ago. I don't know what will happen if when that's in the cloud. We have a defect tracking software that resides in the cloud. It's multi-tenant, and so if you wanted to hack our systems, I suppose you could see all the defects in our products. Yeah, but it's not enough security issue that we're worried. But what it does, we have programmers, developers are distributed, our analysts are distributed. We can 24/7 place the stuff in our defect tracking system, get reporting, etc., without having to host that here. Our product delivery systems are hosted on a server. So if you purchase our products, you get a URL and you can download your software. And the security seems excellent on it. So if you want to hack and get free seer, you might try, but we think it's pretty secure. I can go on and on here. Development servers are still on premises. We have millions of dollars we spend every year on development. We're not comfortable taking that and putting it in the cloud. We have daily tape backups with strict retention policies. Again, we have browser versions of some of our software. We use SharePoint. Now, SharePoint we put on the cloud originally and decided to bring it back in-house because it was lower cost. So the fact, the cloud is always cheaper, not necessarily. We have a VoIP system on premises. We looked at using the cloud for a VoIP system, our phone system, but it was far more less expensive to host that ourselves. Salesforce Chatter is used here. Chatter is software as a service. We have many virtual servers on-house so they can test our products in different environments with Oracle, with Microsoft databases, with different versions of Windows, etc. And the real conclusion to this is, and I first heard Peter Coffey say this a few months back. He said, we don't need to talk about cloud computing anymore. It's just computing. The real key is what do you use when? Whether it's on premises or whether it's in the cloud, in computing, use the tools that are most appropriate and solve your problems and get the return on investments the best you can. So I can't say cloud's cheaper. I can't say cloud's not cheaper. I can't say Galorath's all in the cloud. I can't say Galorath's all not in the cloud. I can't say that we, like everybody else, try to do the analysis and use the things that make the most sense. And my 3 key points: viable affordability decisions yield achievements in projects. Cloud computing usage is becoming viable for more and more situations. And applying affordability processes to cloud computing decisions can ensure a return on investment if you do a good job of it.